Hello, this is Mark from Cabin Tech. I want to give you a quick demo and update on the development of our CT3680 delay module. This module is an analog in, analog out that implements up to 4 delay lines with delay times up to 680 milliseconds. The core of this module is a digital DSP, but from a system design point of view, it's used much like a BBD-based kind of analog circuit. The circuit designer implements various techniques for analog feedback, filtering, modulation, and other processing to achieve some kind of overall effect. There's lots more on this topic in the pedal PCB form. I won't go into all the technical details of the module right now. So let's take a quick look at what's on the bench here. In the center here is the 3680 module. 4 inputs are on the right. We're only using one of them for this demo right now. Input 0, and there are 4 audio outputs on the left, and we're using all of those in this quick little demo we're going to do. The module is configured right now as a single 680 millisecond delay line with 4 taps. The pots along the bottom here generate control voltages that set the delay times for each of the taps, along with some global scaling that we'll talk about a bit later. Next to this on the bench is the new BoardBrain 6-channel CV control rack mixer. This is a really cool little bench tool, although I think it's more designed for Eurorack type environments and live mixing and studio mixing, but it turns out to be a pretty good bench tool for our purposes here. With this, we can easily set up our wet-dry mixes, build feedback paths, loop in external effects. It's a pretty convenient mechanism for defining the infrastructure around the delay path. Our use here today is fairly simple, and I'll describe how the mixer is configured and how it's used in this system in a second. Also in the rack is an LFO from Synthertech that we'll be using in some future experiments. We're not going to be using that today. Over here we have a simple MIDI keyboard and sequencer. I've already put a sequence into it. It's connected to a laptop that has a software synth. So it produces some simple clean sounds that we'll be using in the demo. And the output of the laptop here from that software synth is the input to the delay module. I'll kind of show that structure in a second. Also over here on the bench is the power supply, and you can see in this case we're running 3.3 volts into the module, and it's drawing about 160 mils. You can also supply the module with 5 volts if that's what you have available. The final part of the setup today is a laptop running software that in addition to the software synthesizer, it's also running some software that is live capturing the data out of the DSP and the delay module to show the exact delay times being applied to each of the tap outputs along with the current value of the global scalars. So the demo today is really simple. It's about as simple as it gets. It's just an echo configuration. There's no feedback, there's no filtering, there's no modulation. It's just about as simple of a delay as you can get. And the reason I want to do this first, this is just the raw delay line. So you're going to hear exactly what the delay line's doing without any coloration or processing or feedback or anything else obscuring it. You're hearing just exactly what the delay line is producing. The module, as I mentioned, is configured as a single 680 millisecond delay line. The pots are set to produce the delays that you see here on the screen on the laptop. And these values are coming right out of the DSP to tell us what the delays on the 4 taps are. The mixer is configured to do 2 things. First, it provides gain because the line output of the laptop is quite low. And we actually needed to use 2 gain stages to get to a decent level. So the output of the laptop is fed into channel 5 of the mixer, and then that channel is fed into channel 6 to do a double gain stage, and that gets our gain up to the levels that we need to the module. The output of channel 6 is then the input to the module. It goes to analog input 0. Channel 6 is also fed to the master output of the mixer, and it is the dry component of the final mix. And that final mix is being recorded by another system. The 4 analog outputs of the modules, that is the 4 delayed signals, are fed into the first 4 channels of the mixer. So when those channels are unmuted, they are directly mixed into the master output along with the dry signal from channel 6. So like I say, in this configuration, there's no feedback, there's no filtering, there's no modulation, no other effects are being applied here. It's strictly a delay, which for the delay times that we have set up produce an echo effect. The sliders on the mixer control the relative volume of each one of the taps in the final mix. The way they're set up here, they all contribute about equal amounts. So I'm going to run the demo here in a second. The demo starts with 2 repeats of the sequence. It's about a 12, 16 note sequence. And it repeats that sequence twice at 100% dry. So what you're first hearing here is going to be just the output of the laptop. That is the output of the synthesizer. And the delay module is not even in the signal path at all for these first 2 repeats of the sequence. Then I'm going to unmute channel 1, which will mix in the first delay tap with the dry signal. This is the shorter delay. Then after 2 more repeats, I unmute channel 2, which will add in the second tap, and then 2 more repeats, and tap 3 is added, and then tap 4. All the taps are muted again after tap 4 has been added and goes through 2 cycles of the sequence. All the taps are muted again, and you'll hear the dry signal back again. So on a technical note, the recording that you're going to hear in this video is the main mixer output exactly as captured, no editing or modifications. It's just exactly what was produced and recorded on the mixer output, not this microphone that I'm wearing to do the narration here. Other than that, there's no modification to the audio except, of course, the video encoding and that's being done in the video and the decoding done by your video player are also involved in the audio processing, of course. But basically, what you're hearing is what it sounds like. We're going to go ahead and run this demo. Of course, this demo was just a really simple use of the delay line. In a real effect, there's going to be many other complexities in feedback paths, filtering, modulating delay times and amplitudes, lots of complexities in a real effect design. But I wanted to show here what you can hear just from the delay line itself, because that's kind of the core of the system. What you can build on that, of course, can be very complex and much more interesting than the simple echo effect. There's been a fair bit of discussions on some of the forums about some of the BBD modulation techniques, in particular modulation of the delay time. So we're going to do some experiments and some comparisons along those lines shortly. But right now, our priority in the immediate future is to get the rest of the prototype modules built and sent out to our beta testers. We're pretty satisfied with this first pass of the hardware. The prototypes run well, they run reliably. The firmware is mature enough, I think, that we can let people start experimenting with it. We're going to get the rest of the modules built over the holidays, I hope, and get them sent out to the beta testers first week of January. That's kind of our current plan. Then we're going to follow up with some additional demos around some specific topics like delay modulation, other ways this module can be configured, and so on. We'll talk about some other things there. But that's it for now. Feel free to contact us if you have any questions, post on the forum, whatever. Thanks a lot.